Chapter 8 in Final Series Definition. Sequence is the FN and FX is a host to many is a set of natural numbers and whose range is a subset of real numbers. Example e.g. example greta for x is equal to function 1 upon n plus 1 domain is 1 2 3 so on to uh, infinity. In range is equal to 1 upon 2 1 upon 3 and 1 upon 4 so on to infinity. 1 हमें ऐड करते जाना है डोमेन से और रेंज हमारी 1/2 1 3/2 4 we get and generate sequences denoted by an and our an is equal to n term of sequence. Infinite sequence has infinite number of term e.g. 1 upon 1 1 upon 2 1/3 so on to 1/n. अगर हमें गिवन टर्म अननोन है या फिर इनफाइनाइट है, अनकाउंटेबल को इनफाइनाइट सीरीज कहते हैं और फाइनाइट हैज़ टर्म मैक्सिमम 100 और 20 और 1000 terms has a finite number we can count easily. Convergence of a sequence. An infinite sequence an is said to be convergent if any term of sequence tends to the definite real numbers L as n approaches to infinite, that is dt upon n approaches to infinity an is equal to L for a constant हो और divergence non. Divergence of a sequence. Divergent infinite number of term होती है a sequence. An is said to be divergent if any term of sequence tends to infinity plus minus infinity. As an infinity, that is dt and approaches to infinity and an is equal to plus minus infinity. Bounded above. If p is a fixed number such that an less than b. For example, if series is given or said to be is less than or greater than an series of natural number or with this given term 1 upon n plus 1, this condition if or a series formula for or function given हो or less than or equal condition हो an is less than b for every positive integral value of n, then we say an sequence is bounded above, bounded below. अब हमारी अपर बाउंड्री होती है और लोअर बाउंड्री होती है. अगर अपर केस है, अपर बाउंड्री है तो अपर अबव और लोअर और बिलो बाउंड्री, लोअर वैल्यू है तो बाउंडेड बिलो है. If b is a fixed number such that similar condition 1 upon n plus 1 है, पॉजिटिव नेगेटिव है, बाउंडेड है, 1 2 3 नहीं लिख सकते फॉर, तो ये हमारा बाउंडेड फंक्शन है. फिक्स्ड नेचुरल नंबर होल नंबर नंबर सच दैट ए एन इज लेस देन बी or equal to b for every positive integral value of any term, we say an sequence is bounded below. Bounded sequence is a sequence which is bounded above and bounded below. Monotonic sequence. Monotonic sequence. If a sequence an is said to be, for example, an is equal to for infinity and n is equal to 1 and only an is equal to a1 a2 and a3 so on. For an is less than equal to m, this condition is called monotonic, and for all n is equal to 1 m is less than equal to a, n for all value n is equal to greater than 1. And non-decreasing if an plus 1 less than or equal to an for all n. Non-increasing if n plus 1 less than or equal to an for all n. तो फर्स्ट कंडीशन अगर हमारा 1 2 3 4 गिवन है तो ये हमारा इंक्रीज नहीं हो रहा है, ठीक है। ये हमारा 1 2 3 कंडीशन वन सीक्वेंस है, नॉन डिक्रीजिंग और नॉन इंक्रीजिंग, बट 2 से अबव 4 8 6 ये हमारी इंक्रीजिंग कंडीशन बताइए। 10 20 30, 10 के बाद 20 आ रहा है, 20 के बाद 30 आ रहा है, ये इंक्रीजिंग कंडीशन है। For is strictly increasing if an plus third condition n plus 1 is greater than an for all n. Strictly decreasing if an plus 1 less than an for all n. यहाँ 5 4 3 2 1 ये हमारा डिक्रीजिंग कंडीशन है। 5 के बाद 4 आ रहा है, 4 के बाद 3 and 2 and 1. Note, a convergent sequence is bounded but a bounded sequence need not to be converges. आंसर हमारा इन्फिनिटी आए तो हमारा हमारा जो कन्वर्जेंट हो डाइवर्जेंट है, अदरवाइज कोई कांस्टेंट है या फिर काउंटेबल कंडीशन है तो वो हमारा उसे कन्वर्जेंट कहते हैं। A bounded monotonic sequence is a convergent. A bounded above and monotonic increasing sequence is convergent. A bounded below below monotonic decreasing sequence is convergent. And under bounded sequence is divergent sequence. कोई भी condition f of x से series बनाना. For example, exercise 8.1. The inner term of the sequence is given. Determine whether the sequence converges or diverges. If it converges, find its limit. First question, 2 upon square root of n square plus 3. Solution, we have an is equal to 2 upon square root of n square plus 3. Limit an पर हम लिमिट अप्लाई करते हैं, n approaches to infinity. That is equal to limit n approaches to infinity to upon square root of n square plus 3. अब इसे मिनिमाइज के इधर के फंक्शन हमारा ज़ीरो ना हो कंडीशन लगाते हैं, 2 कॉमन ले लेते हैं, n होल कॉमन ले लेते हैं, स्क्वायर रूट ऑफ 1 प्लस m अपॉन n स्क्वायर इज इक्वल टू 2 square root of 1 plus 3, but an something is divided by infinity is 0, so the sequence is an is convergent having limit 0. Question number 2, n minus 1 minus 3 factorial upon divided upon or n minus 1 factorial sequence. Solution, an term is, we say this is an term, nth term of given of any sequence is equal to n minus 3 factorial upon n minus 1 factorial. Limit n approaches to infinity, an is equal to limit n approaches to infinity, n minus 3 factorial upon n minus 1 factorial. Limit n approaches to infinity, nth term of any sequence an is equal to limit n minus 3 factorial. अब हम इसे जो है we know that n minus n factorial is equal to n 1 degree n into n minus 1 n minus 2 n minus 3 so on to 1 factorial. So हम इसे डिक्रीज करते हुए कट कर देंगे. n minus 1 n minus 2 is the n minus 1 and n minus 2 सिंप्लीफाई करने से आंसर आ गया. अब हम इसमें लिमिट लगा देते हैं. समथिंग प्रोडक्ट करेंगे विद इन्फिनिटी टू इन्फिनिटी होता है, and dt n approaches to n is equal to a n is equal to 0, the sequence a n converges to 0. So something is divided by infinity is equal to 0, so the answer is 0. The function is converges. अगर हमारा आंसर इन्फिनिटी आएगा तो हम उसे फंक्शन को डाइवर्जेंस कहते हैं या डाइवर्ज कर रहा है गिवन सीक्वेंस और टर्म कंडीशन.